In this video, you will learn about the graphs of linear equations in two variables. Now, as we begin, there are some terms to know. So we begin with the term coordinate plane. Coordinate plane is this plane you see over here on the right. So it's where we're going to graph different things. So this is a coordinate plane, and another term we give to this is sometimes called the Cartesian plane. And that is named after René Descartes. So Cartesian for Descartes. So on the Cartesian plane, or on the coordinate plane, we have what is called quadrants. So quadrants are each part of this coordinate plane. So we see this is divided into 4 little squares. So each square is called a quadrant. So we have quadrant 1 on the top right, quadrant 2 on the top left, quadrant 3 bottom left, quadrant 4 bottom right. It is important to know which quadrant is which, so make sure that you notice the fact that 1 starts on the top right and then it goes counterclockwise. Okay? And from here we also have what is called the origin, which is going to be this point right there, where these two lines intersect, where this vertical line and horizontal line meet. Those horizontal and vertical lines are called axes, which is plural for the word axis, which is A-X-I-S. So we have two different axes, one that goes left to right, and that is called your x-axis. So that would be right here, this line. And then you have the y-axis, which is the one that goes up and down like this. Now, if you want maybe a way to remember which axis is which, one way that you can maybe remember is that the letter y, if you extend this part of the y down, it's going to be vertical. So the y-axis is the vertical one. It goes up and down. We also have some more terms to know. We have what is called the ordered pair, which we have previously discussed, but that is made up of an x and a y value. So for example, 3 comma y, or 4 comma negative 2, those are ordered pairs because we have two pairs, or I guess two numbers that are paired together. Next we have what is called the abscissa, which is really not a term that's used too often, but it will be the x coordinate of the ordered pair. So this 3, that would be your abscissa. The y value is called the ordinate. So that is the y value of the ordered pair. So the 1 right there, for example, would be called your ordinate. Okay, also some more terms to know. We have what is called the domain, which are all the values of x. So if you had a list of ordered pairs like 3, 1, 4, 6, for example. So the domain are all the x's. So 3 and 4 together would be your domain. So that is different than abscissa, because abscissa is just one of the x values. So like 3 is an abscissa, 4 is an abscissa, but put it together with all the x values, that is called the domain, which in this case would be 3 and 4. We also have the range, which are all the values for y. So here 1 and 6, for example, would be your range, because those are all your y values. Next, we need to know how to graph ordered pairs. For example, if we had the ordered pair 3 comma 2, how would I graph this? Well, 3 are your x value and 2 is your y value. So x is left and right. Okay, this line horizontal is going to be your x-axis. So if I go 3 in the positive direction, positive 3, that will be 3 to the right. So I go over 1, 2, 3. That takes me right here to this point. And then I have the 2, which is your y value. Your y-axis is this vertical line, the one that goes up and down. 2 is positive, so I go up, which is the positive direction. So I go over 3 and then up 2. That takes me right there to this point. That is 3, 2. Next, we have 0, 4. Now be careful when you have 0 for something. Make sure that you're going in the right direction. So here, x is 0, which means it does not go left or right. 4 is your y value, which means it goes up 4 because 4 is in the positive direction. So it does not go left or right, but it goes up 4, which would take me right here. Next we have -3 and -1. So x is -3. Negative will be to the left. Okay, so if right here is 0, we go to the left 3, 1, 2, 3. That takes me right there. And then down 1 would be right at this point. So to the left 3, down 1, down because it's -1. That takes me to this point right there. If I had 2, -3, x is 2 and y is -3. So 2 would be in the positive direction for x, which would take it to the right. 3 is negative, and that is your y value. So y is negative when it goes down. So it goes down 3. And that takes me right there. So 2 to the right and 3 down. One more, we have 2, 0. So in this case, x is 2. So I go to the right 2, because that is my positive direction. And then 0 is up or down, so it goes up and down 0. So it just goes 2 to the right, and that's it. It does not go up or down. Next we have a theorem that discusses what happens when you graph an equation in two variables. So if you have an equation written in the form ax plus by equals c, then it will form a line when graphed. So equations that look like this are called linear equations because they create a line. So for example, a, b, and c can be any number. So 2x plus 3y equals 4, for example, would be linear because a would be 2, b would be 3, and c is 4. So this equation, when graphed, would make a line. Now, a, b, and c could be fractions or negative or decimals or whatever. So here we have another example. Negative 4 over 3x plus 5y equals 9. This would also be linear because we have ax plus by equals c. Y equals 3x minus 1 would also be linear because we have something with the y and then something with the x and then a number. Alright, so the number with the y would be a 1 in this case. And I can rearrange this to look more like the original format. So if I wanted to, I could bring the 3x to the left, and it would be negative 3x plus 1y equals negative 1. And that would look more like the other two types of equations that we had written right here. Next we have x equals 1. That would also be linear, and the reason is because there would be 0 y's. So for example, I can think of this as 1x plus 0y equals 1. So a, b, or c could also be 0. Alright, so in this case, b would be 0, and then a would be 1. It's the number with the x term, and then c would be 1 as well. So that is also linear. If we had y equals x, this would also be linear because we can rearrange this to look in this format. We would have x minus y equals 0. We would bring the y over here. X minus y is 0. So x would be, or a would be 1, b would be negative 1, and c would be 0. Now examples of not linear equations would be something like this. X times y equals 7. Notice in this format we need x and y being added together and there could be something with the x and the y as well. Here, x times y is not linear because it's being multiplied and not added together. 2x squared plus 3y equals 7 also is not linear because of this exponent. All right, that would make it what's called quadratic, and that would not be a line, that would be a parabola. If we had division, so like 3 divided by y, that is also not linear because notice right here, we need b times y, something times y. We cannot have 3 divided by y. That is not linear. And this format, by the way, right here is called standard form. So if you have the x and y on the same side equaling a number, that is standard form. So in more specifics, some examples would be 3x minus 4y equals 6. We have x and y on the same side equaling the number on the right side. 2x plus 5y equals 10 would also be in standard form because we have x and y on the same side equaling a number. X equals 2 would also be standard form because there's 0 y's. So we can think of that as 0y plus x equals 2. That's standard form because x and y are on the same side. In this case, there is no y, but the number is on the other side. Same thing with y equals 4. There's 0 x's. So x and y are kind of on the same side, so to speak. And then the 4, the number is on the other side. Here are some examples of not standard form. First would be 1/3 x minus 2y plus 6. And the reason is because we cannot have fractions. So if you notice right here, as a little side note, a, b, and c must be integers. Integers would be numbers like 1, 2, 3, or -1, -2, -3. Numbers that are not fractions. So 1/3 would not make this standard because we cannot have fractions. Y equals 2x minus 4 also is not standard form, and the reason is because we need x and y on the same side. So that is not standard form. This is not standard form either because, once again, x and y are on both sides this time. We need it combined onto one side. So that would not be standard form as well. Now, working some more with these linear equations, we need a little review from geometry. So if you're trying to graph a line, how many points are needed to determine where a line will go? Well, the answer is going to be 2. We need 2 points to determine where a line will go. Right? If you had just 1 point right here, and you said draw a line through that point, well, it can be any number of lines, right? You could go like this, you could do this. There's an infinite number of lines you could create. So to know which direction it's going to go, we need a second point, and once we have the second point, now we know for sure, okay, hey, it's going to go through these 2 points, so it's got to go like this. And that's the only way to get that line. So when you're graphing linear equations, you need 2 points to graph. So what I can do is I can find any 2 points, it doesn't matter where. Okay, it's still going to be the same line, no matter where the points are. But we need to figure out 2 points that would make this statement true. So to find that, we can plug in numbers for x or for y. It doesn't matter which one, and it doesn't matter what number. But I'd recommend plugging zeros in because zeros will make things a lot easier. So for my first point, I can plug a 0 in for x and get 3 times 0 plus 2y equals 4, which would be 2y equals 4, so y would equal 2. So my first order pair would be 0, 2, and we can graph that right there. So we have 1 point. Now we just need one more point and we can finish the line. So if we plug a 0 in for y for the second point, we would get 3x plus 2 times 0 equals 4, So 2 times 0 is 0. So I have 3x equals 4. Divide both sides by 3. So x would equal 4 over 3. So my ordered pair would be 4 over 3, comma 0. So to graph this, we have to know what 4/3 is. 4/3 would be 1 1/3. So that means for x, I go to the right 1 1/3. So I kind of estimate where it's going to be. And it's going to be somewhere around there. And 0 would be my y value. So it goes up and down 0. So I have my 2 points, 0, 2, and 4/3, 0. I connect the dots to make my line, which would look like this. So once again, we don't have to use zeros, but zeros typically are going to be easier to work with. Here's another example. We have 2x minus 3y equals negative 9. So to graph, I need 2 points. And again, usually zeros will be the easiest to work with. So let's plug a 0 for x for the first point. So here I'd have 2 times 0 minus 3y equals negative 9. 2 times 0 is 0. So I have 0 minus 3y, which is minus 3y. And that's equal to negative 9. And then to solve, I need to get rid of this negative 3, which is being multiplied. And I get rid of it by dividing. So divide both sides by negative 3. I have y on the left and positive 3 on the right. So when x is 0, y is positive 3. So my ordered pair is 0, comma 3. And to graph this, I go over 0 and up 3 to get this point right there. Now to find my second point, I can plug some other number in. And let's plug a 0 in for y this time. So now we have 2x minus 3 times 0 equals negative 9. 3 times 0 is 0, so I have 2x minus 0, which is 2x. So 2x equals negative 9. I can solve by dividing both sides by 2. Now I have x on the left and negative 9 over 2 on the right. So my ordered pair is going to be negative 9 over 2, comma 0. And negative 9 over 2 is the same thing as negative 4.5. So my point is negative 4.5, 0. So negative for the x value is going to go to the left. So that's going to be 4.5 to the left, which would be about right there, between 4 and 5. Now I have my 2 points. I can connect the dots, and I get this line right there. Now to finish off this lesson, we need to know how to graph lines that look like this, where we have 0x and then a y equals something, or let's say we had 0 y's, so it's x equals something. Well, here we are working in 2 dimensions, so we have this coordinate plane we're graphing in. If it was in 1 dimension, it would be graphing on a number line, and it would just be a point on the number line. But here, since it's 2 dimensions, we need a line. So the best way to think of this is we need 2 points, right? So let's plug in values for x. Let's say x is equal to 0. When x is 0, what is y? Well, okay, y is 2. So there is no x though. But what that means is that y is 2 no matter what. So if x is 0, y is 2. If x is 1, y is 2. If x is 4, y is 2. So I have all these different ordered pairs, 0, 2, 1, 2, 4, 2, whatever. If I plot all of those, I'm going to get a horizontal line like this. 0, 2 would be right here, 1, 2 would be right here, 4, 2 would be over here. Okay, it doesn't matter, we're going to get this horizontal line. So y is 2 no matter what, and this is my graph. So if y is negative 1, it doesn't matter what x is, y will always be negative 1. So it's going to be a horizontal line like this here at negative 1, because on this line, y is always negative 1. X can be anything. Y will still be negative 1 on this line. Now what if you had x equaling something? Well, same concept. It doesn't matter what y is equal to, because y does not affect x in this case. X is 3 no matter what. So if y is negative 1, x is 3. If y is 0, x is 3. If y is 2, x is 3. So we have all these different points, 3, negative 1, we have 3, 0, 3, 2, etc. No matter what, x is 3. So if I were to try graphing some of these, x is 3, y is negative 1, that'd be right here at that point. 3, 0 is right here. 3, 2 is right here. Connect those dots, and I have a vertical line in this case that goes through all 3 of those points. So with this vertical line right here at 3, it doesn't matter what x is equal to. X can be anything, or sorry, y can be anything, but x will always be 3. Alright, it doesn't matter what y is equal to, x will always be 3. So if x were something different, maybe negative 2. So if x is negative 2, that means we have a vertical line at negative 2. So right here with this vertical line, y can be anything. Y can be 0, negative 8, y can be 100. It doesn't matter, x will always be negative 2, which makes this vertical line. And that concludes our lesson for today. We will see you next time.